During a high school football game, the height of a punt can be modeled as a quadratic function of time, where t is the number of seconds which have elapsed, and h of t is the number of meters above the ground after t seconds. So we're not going to use a graphing calculator for this because we don't really need one. We're going to figure out the maximum height of the football. Now you remember, maximum refers to the y of your vertex. In this case, because this is negative, we know we have a maximum rather than a minimum. Your vertex is going to be right here. So I'm just going to write that out. Your vertex, it appears to be 1.5 and 12.25. Okay, the y of your vertex is going to be your maximum. So this is telling us that the maximum height of the football is 12.25 meters. So the next question is what is the time it takes for the football to reach its maximum height? Well, you get that from the vertex as well. That will be your x. That's going to be 1.5 seconds. Then you have the height of the football above the ground as the punter makes contact with it. What we're talking about is time and the height. Well, when the punter makes contact with the football, this is at time 0. So with t being time, all you do is you replace t with 0. So h of 0 is going to be -5, and you've got 0 minus 1.5 squared plus 12.25. When you follow BEDMAS rules, of course, start with your brackets, then your exponents, and then multiply and then add after that, you should get an answer of about 1 meter off the ground. Last but not least, we have the height of the football above the ground 0.5 seconds after contact. In that case, replace the t with 0.5. So h of 0.5 is going to be -5, and you're going to have 0.5 minus 1.5 squared plus 12.25. When you work that one out, that's going to be about 7.25 meters. Remember to follow BEDMAS rules. Okay, so if we had to draw this out, it kind of looks like this. We've got a parabola that faces down like that. It's going to end at the ground. What we have is we've got a y-intercept here. This is where the punter makes contact with the football. It's going to be at 0 and 1. Okay, so at 0 seconds, it's 1 meter in the air. Your vertex is about there. In that case, it's going to be 1.5 seconds, and at that time, it's going to be 12.25. And that, of course, is your maximum. For this part, we have to use the graphing calculator. So you can sketch this graph on your calculator, and you can verify everything we did previously by hand. But we can also determine how many seconds to the nearest tenth. The football is 10 meters above the ground. Problem is, of course, h of t is going to be your height, and that corresponds to your y-axis. So there's a little bit of a procedure you have to do in order to figure that out. Okay, so remember, the h of t, or your height, is going to be your y-axis. So what you need to do is you need to put in y1 the original equation. Okay, and in y2, what you're going to do is you're going to make that equal to 10 meters, because that's how high we want the football to be. You'll notice, though, that it's going to cross the parabola in two spots, right here and right here. Okay, so those both are actually kind of important. Here's how you're going to do it. You're going to use a feature on your calculator called intersect. Intersect is found, it's number 5. It's going to be second function trace, just like before when you were looking for the zeros, the minimums, and the maximums. This time around, you're going to use the intersect feature. That's number 5. Okay, so once you've got that, it's going to come up just like what you've done before with zeros. You're going to have your first curve. So what you want to do is you want to place your cursor just underneath where the intersect is going to be, on this side anyway. Think of it like before. Roller coaster's going from left to right, and it's going to go up and down. Okay, so place your cursor just underneath for the leftmost intersect. You'll notice, though, your second curve, the cursor is actually going to be on the straight line that you had made. That was y is equal to 10. Okay, so you just want it to the right of the intersect. So you notice here's your first cursor, this is your second cursor, and your intersect is just in between. You hit enter, then you hit guess, and you should be able to get your result. In that case, this is going to be 0.8 and 10. So what this is saying here is that at 0.8 seconds, the ball is 10 meters in the air. Now, of course, you're going to do the same for the second one. You're going to place your cursor just above it, and then just to the right, so your intersect is somewhere in between here. And what you're going to find for the second intersect, it's going to be 2.2 seconds and 10 meters, because the football is going up and then it's going to go down. So there's going to be 2 times during this action that you're going to be at 10 meters above. In C, the punt is not caught by the opposing team and the football hits the ground. Use the features of the graphing calculator to determine how many seconds to the nearest hundredth it took the football to hit the ground. Your height is going to be 0. Okay, so what we want to find out is at what seconds. Okay, so this, of course, if you think about it, is going to be something seconds and a 0. This is an x-intercept. Okay, because this is your height and this one right here is going to be your time. Okay, so what you're going to use is you're going to use the 0 function in your calculator and pick the one that's going to be positive, and that's going to be 3.07 and 0.